As we face the impacts of a changing climate, there are practices such as reduced tillage or no-till that can help us make sure that we can be more resilient with our operation. This not only allows us to use the moisture we do receive more efficiently, it also helps us recycle our nutrients in a more sustainable manner. One of our most important nutrients, nitrogen, is a very large expense on the operation and is very necessary. We need to make sure that we're getting that nutrient to our crops, instead of that leaving the system, not only having impacts on the environment, but also a reduced return on investment for that farmer. And there's a lot of research being conducted on how do we improve those efficiencies. University of Minnesota and Klinger in Southeast Minnesota have been doing a lot of research on how do we fit this into our operation and what are the impacts long term.
We're at a University of Minnesota research location just east of Rochester, Minnesota, at the edge of what's known as the driftless region of southeast Minnesota. We do research here primarily on the corn and soybeans that are grown in the area, but other crops as well. There's a wide variety of research being done on this farm. There's always some weed management and other just general agronomic trials, usually some different varieties of soybeans and corn being tried out. The trial I'm most familiar with here is what we call the long-term nitrogen research trial, where they're looking at different rates of nitrogen fertilizer being applied over many, many years. So essentially, some plots get no nitrogen for year after year after year, and other plots get different rates consistently on those corn acres or those corn years. And what they end up doing is actually looking at how does that change nutrient management, how does it change the soil. Now, there's many, many different things you can look at from that, including things like how does it translate into organic matter and soil carbon storage. These research trials are done rotating corn and soybeans. So the trial that I'm talking about is in its soybean year. I'm looking and I can see a few little differences across the plots, but for the most part it is not obvious. These plots, some of them have had no nitrogen fertilizer for years during the rotation, and some have had an average of 120 pounds an acre per year, 240 being applied in the corn year. And you really don't see a whole lot of differences, at least my eye can't tell. But again, in a corn year, it would be, in most years, it would be significant. The soil on this particular farm is about as good soil as you could ever find anywhere. Formed under grasslands, no restrictive layers 5, 6 feet down. Corn roots will go all the way down there. That makes it really, really nice in terms of being able to recover nutrients like nitrogen that get lower in the soil profile, just free water movement up and down. These are fairly small research plots. It might extend for 300 yards or 400 yards of field, but you'll see every once in a while as you walk, you get a nice little gap, which is kind of the alley. You have big buffers essentially between different treatments you're doing in terms of research. This whole farm has been under research management for quite a while. There's a range of things that colleagues do research on here, which could be just general agronomy in terms of hybrid selection or weed management or nutrient management. There's been a lot of research here on phosphorus and potassium management in the past. There are a lot of direct benefits of a long-term nitrogen rate trial for farmers, and it's an experiment that a farmer is not going to readily do themselves, because what we have here are the same corn-soybean rotation year after year getting no nitrogen at all, or getting very high rates of nitrogen and everything in between. And no one is going to do that experiment on their own farm, except for maybe in very small areas, because the risk is too high. What we're seeing here is essentially a very long-term drawdown of nitrogen when you're getting no fertilizer to a very rapid, potentially buildup of nitrogen where you're getting very high rates of fertilizer. And so it allows you to look at how does that impact that field over time. Because one of the things we know is that nitrogen generally doesn't stick around very readily. We lose a lot of nitrogen. If there's a lot built up in the soil, it tends to get lost when it gets too wet or potentially too dry out into the air or down to groundwater. But we don't know how much of it is always being lost. And so one thing you can start to look at is the organic matter in a field starting to build up nitrogen over time if the rates are quite high? And likewise, you can look at what happens in terms of how much nitrogen is being released from organic matter over time if you have no fertilizer being added. And it gives you this range of conditions that help you understand how all of those things just impact the soil itself. So in general, Nitrogen is one of the nutrients that crops need in the greatest abundance. It creates the greatest response in terms of crop yield. Nothing else short of weather conditions really has quite the same impact in the potential to hurt yields. So it's really critical to figure out what is an appropriate nitrogen fertilizer rate for a given field. And those things vary quite a bit from year to year. Typically, you'd have fairly significant rates applied to corn and usually none on soybeans. In our part of the country, we're blessed with very high native organic matter soils, which means that they have quite a bit of nutrients in them like nitrogen and carbon already stored. In this part of the country, we actually get a very substantial amount of nitrogen from organic matter itself, when we can almost think of fertilizer nitrogen that a farmer would buy and have applied on their field as being almost a supplement to what's already in the soil. This research trial is, again, looking at different rates of nitrogen fertilizer being applied over long periods of time, and they're doing that over larger areas of the field. But then within that, they're also comparing, if we use different sources of fertilizer, different forms, does that change the dynamics that we see within the field? And so they're looking at pre-plant urea is kind of the baseline, but then one of the other things they're looking at is a mix of pre-plant urea with what we'd call a slow release form of urea, which is basically a fertilizer product that's designed to not release all the nitrogen all at once, but time it to when the crop is actually using it. So one of the things that people talk about in terms of climate smart agriculture is greenhouse gas emissions associated with agricultural production. And one of the big components of that is nitrogen fertilizers, really for two reasons. One, nitrogen fertilizers take a lot of energy, at least the way they're currently produced, and so they result in a pretty high direct impact in terms of greenhouse gas emissions. The other thing you have to consider is the release of nitrogen greenhouse gases like nitrous oxide. Soils are always, because they're filled with lots of microbes that are living and dying and breathing all sorts of different things and eating all sorts of different things, they're constantly releasing gases and also absorbing gases. So when we talk climate smart agriculture, a lot of that is, can we absorb carbon dioxide into the soil? But it also works for nitrogen. And nitrous oxide is one of these things. You have microbes in the soil that produce nitrous oxide as part of their lifestyle, and you have microbes in the soil that will essentially break down or use up nitrous oxide as part of their lifestyle. When you get into very nitrogen-rich environment, anything that has a lot of available nitrogen tend to shift the balance a little bit so that a soil is producing more nitrous oxide than it's consuming. It is a potent greenhouse gas. Trying to minimize the amount of nitrous oxide that a soil is producing is a really important component of lessening the greenhouse gas impacts of agriculture. In order to do that, there's a number of different things you can do. The one thing to think about, of course, is just how much nitrogen is in that system at any given time. And what we see is that, of course, a higher nitrogen fertilizer rate, let's say, is usually going to correspond to higher nitrous oxide production from that soil, all things being equal. So one part of the solution, potentially in certain situations, might be lower nitrogen rates. But there are other things that are really important here, and there are a whole host of different types of fertilizers. I mentioned earlier what we call slow release nitrogen fertilizers. These are urea fertilizers that are actually coated with a polymer that, in order to let that urea out into the soil, water has to come in through little pores in the polymer and dissolve some of it and pull it back out. And what ends up happening is that it takes a significant portion of the growing season for all of that to be released. And what it means is that at any given point in time, you don't have a huge surplus of nitrogen to what the crop can use. And so there's less greenhouse gases from nitrous oxide that would be associated with fertilizer in that form. And similarly, there's products called nitrification inhibitors, which, while they have a different kind of mode of action, they're actually affecting biology in the soil and kind of slowing the activity of certain bacteria. They have a similar effect. They slow down the accumulation of the forms of nitrogen that can result in some greenhouse gas emissions as nitrous oxide, and they just make it so you get less overall in general. So those two things, they don't solve the issue, they don't completely eliminate nitrous oxide losses, but they end up being a pretty important component of actually just reducing the risk and lowering the overall amount of losses. And then the last thing we do talk about in terms of reducing nitrous oxide emissions would just be the timing of nitrogen application. So I don't think the research is quite as clear, but There's a significant potential impact of splitting nitrogen fertilizer several times during the season and ending up with a little bit lower nitrous oxide emissions just because you have less available at any given time. So that's really what you're doing. You're just trying to mitigate some of that risk of loss, and loss of nitrogen is really what leads to nitrous oxide emissions. But in any case, once you get above a point where that fertilizer is maximizing that production of organic matter, you're not really gaining anything in terms of carbon sequestration, and you're losing more in terms of nitrous oxide emissions. So there's a lot of research that is oriented towards what is the best nitrogen rate for your management system that you can apply in a field, and how is that going to vary from year to year, which we know it will because of weather and climate conditions. In some ways, it's kind of a good thing, right? Because nitrogen loss is what causes nitrous oxide emissions. Nitrogen loss also causes yield losses, and so the same sort of things that are going to lower the amount of nitrous oxide emissions you see and limit some of those greenhouse gas emissions are the same sort of things that help mitigate the risk of yield loss in your corn, for instance. Based on the research that's been done here and elsewhere, one of the things I'm very interested in is things like slow-release fertilizers. What are their benefits over a traditional pre-plant urea source? Especially when you get into very poorly drained, so heavy clay soils that tend to pool a lot of water. Those fertilizer products tend to start to show quite a bit of benefit. They're more expensive. There's this push and pull. Is this product providing me more value in terms of ecosystem benefits, in terms of mitigating some of the risk of yield loss, in terms of profitability? Is that providing more than it's costing? That calculus changes for every different person. But there are a lot of things we know, and a lot of them relate to weather and climate. So we know certain types of nitrogen loss are more common in a drier climate or a drier year. If you have a dry spring, I'd be more worried about nitrogen loss to the air just from what we call ammonia volatility or volatilization than I would be about groundwater loss or other forms of nitrogen loss. And that's what I'd be more focused on managing for. But if I'm in a wetter year or in a wetter climate, so this part of the state in particular, it's much more worrisome to me. I focus a lot more on controlling losses that are associated with too much water. And that would be potentially by split applying nitrogen or using slow release products or using nitrification inhibitors. Just things that cut down a little bit on the risk. It's been a few years now, but we've seen some very wet springs in southeastern Minnesota that really cause some issues in terms of nitrogen management. They also do have an impact in terms of other issues that get talked about quite a bit, like groundwater quality and nitrate leaching down through the soil into groundwater aquifers. Those impacts are maybe a little bit lower for preventing groundwater issues than they are for the nitrous oxide emissions, but they're there. So when we think about trade-offs of any sort, one that comes to mind is chasing profits versus chasing yields. And you have to do both to some extent, but we do see with fertilizer management that there are tipping points above which, if you're applying, let's say, 50 pounds more nitrogen than what was needed by your crop in that year, which you don't always know in advance. You don't know in advance. But if you're applying 50 pounds more than you ended up needing, that nitrogen doesn't stick around. And so it's not building any sort of yield for you, but it is costing you money. And prices of fertilizer have been high and very volatile. That is a very significant issue, where at the extremes where it ends up potentially costing you more money than it is providing in yields. And if you look at all the research institutions across the Midwest, their nitrogen fertilizer recommendations are actually based off of profitability. They're all about probability. We know nitrogen management is really a risk-filled enterprise. You don't know what the weather's going to be like next week. You don't know what the weather's going to be like across your growing season. You can guess about some averages. And because of that, and because weather drives a lot of nitrogen management and a lot of nitrogen loss, you don't always know what your best rate or your most profitable rate is going to be. But when you start to look at, under these wet year conditions or dry year, normal year conditions, what the averages have been in terms of what's most profitable, you start to get a better picture of what kind of ballpark you should be on given your management conditions, your soil types, and so on, to maximize profitability. There are a broad range of activities that producers can do that can decrease greenhouse gas emissions associated with agriculture. Some of the most directly obvious would be related to just fuel costs. So reduced tillage, reduced passes through the field is one significant thing that doesn't always get talked about, but it is a very direct impact right there. You have less release of CO2 coming immediately after that tillage from the soil itself, which is a huge store of carbon. When we're talking 5–6% organic matter soils, we're talking thousands of pounds of carbon per acre being stored there. When you go through with a tillage pass, whatever that is, whether it's chisel plowing or ripping or even just vertical tillage, you can actually measure very shortly thereafter a big spike of carbon dioxide that comes out of the soil associated with the breakdown of that tillage. And so by reducing tillage, that does potentially have a significant impact on the amount of carbon you can store in your soil. There are really three main gases that we think about. They're carbon dioxide, methane, and nitrous oxide. The first thing I would probably look at is, and I'm biased because I'm a nitrogen guy, but nitrogen management, because nitrous oxide is fairly potent as a greenhouse gas, and there are some of these slow release or other fertilizer products have pretty substantial impacts, a lot of research shows, on that overall production and release of nitrous oxide. If it works within your production system to make a change to something like that, or to change the timing of applications, that's a relatively low-hanging fruit. It's pretty quick to adjust that management if it works. And it has the downstream benefit also of potentially mitigating a lot of your risk of just plain old yield loss. Strip till is one of those situations that, in a lot of ways, I think, is the best of both worlds. We live in a cool, cold climate that's pretty wet in the spring, slows down the ability for crops to get out of the ground. Strip tillage, by having that strip that is actually tilled, warms it up significantly, but by limiting the disturbance to a relatively small part of the field, also minimizes the amount of CO2 or carbon dioxide that gets released to the atmosphere from that direct tillage and lessens that impact on the ability of the soil to actually store carbon. So that's one thing. The other thing, which is related and also has the downstream benefits, literally downstream of water quality impacts and helping to prevent things like nitrate from getting into our streams, rivers, etc., would just be extending that growing season by either adding a cover crop or some other way, double cropping, etc., that keeps more living green vegetation during those shoulder months when we still have biological activity. I have seen that many of the people who switch to reduced tillage or no tillage because they want less hours spent out in the field, away from family and working, and they have many constraints in that regard, and that's really a priority for them. Do also switch to using cover crops, which on face value, you'd think, well, that's another thing you have to manage that requires more time. But I have found a number of people in this area who've seen in their fields that cover crop helps make the transition to a very low or no tillage system, just in terms of how the soil responds. And so they tend to like it quite a bit in that regard, in terms of just helping that system work better. So it does seem like a lot of farmers like to combine those two. They work together well. Soil organic matter is really pretty critical supply of nitrogen to a crop, especially once you get June, July, August, that time frame. And it does raise an interesting point about cover crops and just a lot of residue. They have, I would say, a bit of a negative impact early in the season, in terms that residue tends to keep it wetter and cooler, and we don't necessarily want that early in the season. And so farmers have evolved a lot of ways to deal with that. They tend to put more nitrogen close to the seed, relatively close, larger amounts, so that there's more available early in the season. But the flip side of that is that later in the season, that residue also is keeping the soil moist, and it's keeping it a little cooler. And so instead of really hot July day, you can get temperatures 110 plus degrees at surface soil, and of course it's evaporating a lot of water. Now you have something that's acting like a blanket and kind of helping keep those super high stressful temperatures a little lower, but also it's keeping the ground a little moister. And so what we do tend to see is that helps with nitrogen release from organic matter later in the season. That residue in our climate may be a bit of a negative that has to be managed early in the season. Later in the season is a very positive thing. We have a pretty rapidly evolving landscape regarding climate-smart agriculture and money available to help with practices and all of those things. And so if a farmer's looking to make some changes and see what is available in terms of funding, a couple of really good places to start would be your local Soil and Water Conservation District or your local NRCS office, who would have a good sense of what funding is available for what practices. And if you're looking for good research-based information about where the impacts of different tillage, nutrient management practices on your greenhouse gas emissions or on soil quality or just on profitability, the University of Minnesota Extension website hosts a number of good resources related to fertilizer recommendations, soil health and compaction and soil management recommendations, and just general agronomy.
Here at NRCS, we make sure to incorporate the research that's conducted by the University of Minnesota into our recommendations and our standards to make sure that everything fits the whole state of Minnesota in a way that is productive and research-based. If you have any questions about how to more effectively use your nutrients or reduce tillage, be sure to check with your local NRCS office on programs available related to climate-smart agricultural practices that fit into your operation.